morning. My name is Igor Gejdos, and I work at Roche Diagnostics, just down the street. And the last couple of years, I've been working mostly on connecting medical devices to the cloud, using phone apps, and working with a lot of designing the APIs. So today's talk, I'll just go through a very simple example of using the serverless in terms of a computing framework, but also the serverless toolkit, the command line toolkit that lets us orchestrate deploying the serverless. And just a very simple example. But first, I would like to get to know a little bit the audience. So who is familiar with the serverless? Okay. API gateway, Amazon API gateway. The Lambda. Okay, so if I say something incorrect, please let me know. Anyways, the serverless is the way to share responsibility between your cloud provider. We work with Amazon quite a bit, so I do a lot of examples for Amazon. But the idea of serverless as a toolkit is to be independent from the provider. So bear with me if I just use a lot of Amazon terminology, but really the idea is to be a little bit platform independent, but still command line. And the serverless is shared responsibility between your cloud provider and you. So in case of typical EC2, you spin your virtual box and you are responsible for whatever you put on it, install, maintain, security, everything else, right? Managed frameworks, such as the RDS, Relational Data Service, they actually let you pick the platform like Oracle, Microsoft, and then you just manage, but they take care of the updates. So it's a little bit less of responsibility on your side, more responsibility on your cloud provider. The idea with serverless as a computing idea was to give a lot more responsibility to the cloud provider and let you to develop your application. But you have less of a choice. Let's say with Amazon, we have, for relational database, we have DynamoDB. Who is familiar with DynamoDB? We have Lambda available with certain languages, such as Python, JavaScript, and so on. We do get API gateway to manage our APIs, and it's our responsibility to link it together, to orchestrate, deploying these bits and pieces of puzzle. And there's a lot of responsibility on Amazon to make it running. We don't really care about the servers. We do pick the regions and so on. But so there is just a lot more responsibility on your cloud provider, and that's what we mean by serverless. There is also serverless as a the platform available from Amazon, from Azure, from Google Cloud. They call it different things. They call it Lambda on AWS. They use Azure functions or Cloud Functions from Google. And the idea of the serverless as a toolkit, you go to serverless.com, this toolkit abstracts a little bit. And I think it's two kinds of abstractions. Abstraction from your cloud provider, but also abstraction for a developer, because a lot of developers, they have development mindset. I would like to work with the code. I don't want to be bothered by DevOps stuff, the servers, networks, and so on. So a lot of syntax is tailored towards developers. So me as a developer, I can manage my source code. I can manage my Python for the Lambdas, but I can also manage deployment of this Lambda and linking it to API gateway and managing everything from the client and be able to source control, be able to modify stuff on the fly, and not really worry too much about operations, not worry about calling IT to deploy something for me. So really the idea behind the serverless as a toolkit is building serverless apps, building APIs, automation. It's not for everything. It really works well for certain things, like building mobile APIs is one of the examples I want to go through, and really focus on business logic. So as a developer, I want to really focus on my Python code. I don't want to be bothered by other stuff. It's open source, but it's also available as an enterprise version, and should be provider agnostic. But the way it works, you write your serverless YAML file, and then under the scenes, it's still going to use the CloudFormation, for example. If I target Amazon, it's still going to use CloudFormation to deploy my Lambdas and so on. So how do I set it up? I go to serverless.com, and it's using Node.js, so I have to use npm install serverless as a framework. Then one time I'll go to my Amazon Management Console or ask my IT, to get me the user access for my framework. So I need to get the access key. Then I configure the serverless access one time from the command line, and I create a profile. In my case, all the credentials are going to be hidden, and they are going to be under IndyPy talk as the profile name. So in my code, I won't be using my credentials for Amazon directly. I'll just be using reference, and it's all taken care of. And then you may probably use different way to protect those credentials on your clients, but definitely you'll not see it anywhere in your code. When you're successfully installed serverless, it shows up as SLS command on your command line, and you just say SLS. It gives you all kinds of options, and some of them, configure the credentials we just did. Install your package, deploy function, which gives you just option to deploy just one function. Then you can look at the logs, so you don't have to go to your CloudWatch in a console. You can actually, from command line, you can pull the logs for the function. You can remove your stack, which is what we want. We don't want to be attached to it. We want it to be a number, not a name. So you should be very comfortable removing your whole stack and starting from the zero when you make modifications. That's kind of the idea of orchestration from command line. There's a lot of plugins. So when we say this is provider independent, to an extent, sometimes there is some Amazon-specific functionality where I have to grab the plugin that's very specific to Amazon, right? So it's not 100% agnostic, but to an extent, you have to know where you want to be. The example I want to go through will be building a very simple mobile application, create data store, create Python code for my Lambdas, and use the API gateway to publish my APIs, RESTful APIs. And then I'll build, or I'll get SDK so I can build my mobile app. And the app is very simple. It's called PyIdea app. So if I have a Python idea, I'm gonna, type it in my phone and save it in my cloud. It's gonna capture the location, so coordinates. So next time I'm reviewing my ideas, I know where I was. What was I doing when I get these ideas? So that's kind of the very simple, application. First thing, first interface that you will encounter when you're developing a mobile application would be the Amazon API gateway, which is the glue that glues together the client with APIs, but then hooks up to your other components like AWS Lambda, and then the database is DynamoDB and so on. So this is the Amazon way to describe what the API gateway is. It's really just the doors into your cloud service. So first thing I'm going to create is going to be HTTPS endpoint that lets me create my idea. So it's going to be, I'm going to post idea. It's going to store it in my database. Very simple. That'll be my domain. You can come up with your own /PyIdea, and I'm going to post some JSON to it, and it's going to access gateway endpoint. It's going to integrate with my Lambda function written in Python, and it's going to use PyNamoDB Python library to access DynamoDB. So it's all Pythonic. And then I'm going to use CloudWatch to debug because you want to know, something goes wrong. You want to be able to reproduce your error. The Python, enabling the Python to work with serverless, you need to get your first plugin. It's the plugin that's actually it's agnostic to the provider, but what it does, it collects Python requirements. So all the libraries that you reference is going to collect it, and it's going to deploy it with your Lambdas. So it's all automates. It looks for your dependencies, it packages it, and it deploys it to your Lambda, functional. One thing you actually need for this to work, you need Docker, because what it's going to do is going to create a clean Linux Docker image, and it's going to collect these dependencies inside Docker, so you're really independent from your environment, and it's going to zip it up, and it's going to send it to CloudFormation, and it's going to deploy So it's another requirement is the Docker. But once you're set up, installing the Python plugin, essentially what you do, SLS deploy, will go through your serverless file, send it up, SLS remove, destroys the stack. So you don't have to ever go to your management console to do anything. The choice of, so these are my project files, so it's going to grow a little bit as we speak, but your first thing you're going to edit is your requirements.txt file, and then you just say, I'm depending on PyNamoDB. This is my version. I don't need to deploy Boto3 or Boto Core because it's already available. But I believe under the hood, the PyNamoDB is going to use those to access your Dynamo database. The choice, Boto3 versus Pynamo. Pynamo is kind of more Pythonic, it's model-based, so you really create your model. You create a class that represents your data, and you're just going to work directly with that model. You don't have to do too many commands to save data, retrieve data, find something. It's kind of easy syntax. So, and also, I would like to demonstrate the dependencies I need. So it's kind of a good example. The model that I'm creating essentially is going to have some unique key for my idea, description of the idea, and location, and it's going to timestamp on the server. And location is name of the location, latitude, longitude, so it's kind of very simple. So I create my model in the Python file, that uses the PyNamoDB model class and extends it. There are some few things you need to do to iterate over the attributes and so on, but very simple. And then the Python function to create the record, again, very simple. The API gateway is going to send all the path attributes to my function, and I'm just going to process it, get the JavaScript that's posted to me, go through it, create instance of my model class, and save it. So it's very simple. Serverless YAML is the file that glues this together. So this is your deployment file that tells you what to use from your cloud provider, what components. In my case, I want to say, my provider is AWS versus Google versus Azure. Runtime, I would like to use for my Lambdas. The profile is my authentication, and then I deploy my region and stage. Stage is, you can deploy various stages of your APIs, development, production, test, whatever. It's, you can manage your different API versions this way. Also what I need, well, I need to name my plugins. So one plugin I already installed is the Python requirements plugin. The Python requirements plugin essentially, I'm going to say Dockerize. It means it'll use Docker to package my dependencies. Right? And then functions. So this section of your YAML file describes all the lambdas I'm deploying, and it's very straightforward. I'm using create function, which is this function here. The handler is going to be my API, HTTP. The path is the /PyDia. The post is a method. Cross-origin request scripting, I have to say true for the local APIs because it's accessing from different domain, and that's it. So this is really all into it. And I actually I need to also create DynamoDB table. All I'm saying is what is my index built on in Dynamo, and as well as deploy. So few things deploy. It tells me I created this endpoint for you, and since I didn't set up my own domain, it's going to use just Amazon, and it gives you some unique key here in the path, so it's kind of differentiated. And it tells me I created one Lambda function for you, and that's it. I can tell you my tool, and I can start accessing this API, and I'm using the Insomnia tool for just testing it. Essentially, I'm going to create one instance of my idea, attend the IndyPy conference, and I was climbing Mount Everest when I was thinking about it, and it's going to store it right in my, and it's going to timestamp, so create a key, and it's going to tell me I created it this time and was updated this. So it's very simple test. So I was up and running with my mobile API in a quite small amount of code, and I didn't have to do anything on the Amazon console. Everything's command line. And then how does it look? So really, if you actually do go to the console to see what happens, which is sometimes good. So your gateway essentially created the post on /PyDia. It integrated my Lambda, so there is method request, integration request. It's going to do Lambda proxy. Lambda proxy means it's passing the whatever JSON's coming in. And then my response, it describes what's coming back. And that's it. It shows you kind of nice. Yeah, it's hooked up to the API gateway. It's hooked up to CloudWatch. To get the CloudWatch to work, you actually have to set your permissions. So one caveat, when you create your the credentials that are going to be used from command line, you have to give them all the permission they need to deploy all these, all these pieces. And then, actually, you can go to Lambda and see your Python code here, but you shouldn't really edit here. That's why the whole idea is run it from the client, push it, automate, right, everything. And then, but you can see actually all your dependencies here and everything, so it's kind of user-friendly. And actually, you can see the DynamoDB table, and actually one item I created in the table. So, and now I'm going to destroy everything. So remove the stack. I played with it. No name, just a number, and get rid of it. Because I'm going to add some more functionality now. So I'm going to add a list, get, update, and delete. So the idea is to get a list of all ideas, and a couple other methods that are going to use the key to retrieve, get the one, update the one, and delete the one. So I'm going to have full API, so I can do all the operations. And then each of them has corresponding Python function, the list function, get function, update function, delete function. These are using path parameter, so you actually have to put your key or the unique ID on your path to do the RESTful operations. And I think that's it. So the change in the code, I created a couple more Python functions, very simple ones. Like if you use the DynamoDB, the scan gives you all the items. The get, you can actually find it by the key that's on the path. Update, kind of the same thing. It finds it, it sees anything changed, and it'll overwrite the item. And then delete. It's pretty straightforward as well. And then my serverless file, the serverless file, I had to add a couple more functions. So create was already there, which was my original one, right? And then a list, which gets me a list of all the elements. Essentially, I'm saying yes, there is a path, and I'm using get for method to get it, and it links to this function here, the PyDList function in my code. Then so this is a list. For the get, just one of them, I have to say, yes, there is a path parameter, the PyDA key, that's going to be passed to my Lambda function. And then similarly for update and for delete, I have the path parameters. But otherwise, it's pretty straightforward. You have to put your method, and then path parameters. And again, SLS deploy, and I see I actually have now 5 endpoints available to me, and 5 corresponding Python functions. And again, I can use my tool to this is give me the list. I can get just the one, right? I can update, so I can change something here and update, and I can delete, and we have a bug here. So I did it on purpose, so I can demonstrate some of the other features. So interesting thing, when you use the gateway, it doesn't really tell you much what your problem is. It tells you bad gateway, okay? Yeah, anyway, I'm assuming it's a bug because I didn't write any of that. So normally, you can go to your CloudWatch logs and see what happened. Oh, yeah, I misspelled my code. I put a key, PyDA key was misspelled. That's why it's failing. It doesn't find the path parameter of the name. Nice thing about the serverless, I can actually do the same thing from command line. Actually, I can say SLS logs for the function delete, and it gets it from the CloudWatch. So I don't have to, tinker with my console, go there, do some damage. I can look at it from the command line, and I can fix it. So I fix the misspelling, and now I just want to deploy one function. So I don't want to do the whole stack recreation. So you can essentially do SLS deploy function, and then just put function name corresponding to your YAML file. It'll just grab that section of the YAML and redeploy it. So you don't have to redeploy the whole stack. So this is kind of a demonstration, and we fixed it, and it works now. So I was able to delete the record from the database. So a few things about securing the API, because right now it was pretty much open. So fairly simple way to secure your API or make it private. It's not secure because still I need to worry about authentication and the credentials and everything else. But making it private, so it's only accessible to clients that I will share the key with. So you will essentially create API key. API key is passed in a message header as a XAPI key parameter, and it will essentially fail if it doesn't find it, and that the key is cryptographically strong enough. Very easy to do with your serverless framework. Essentially, what you say in your provider, create API key for me. So you don't really type the key in. You don't decide what it's going to be, but you say, I need the API key, give it a name, and when you deploy, it actually is going to create a key and give it to you. You can actually decide not to even show it in your command line output. It can write it in a file, so you can secure it properly. And really, for the endpoints, the only thing you add is the private. True, it means it will require the API key that I just specified. So that's it. So I just go to edit my sections for create list, get. And then when I do SLS deploy, and now I see one more item here. And this is obsolete. I mean, it doesn't work, but you can try. But the idea is you want to protect this, secure, and only share it with the clients that need to have access to the API. And then again, I have all the same endpoints here available, and it's the same functions. But I was able to redeploy the stack again. And really, it takes, depending on your code, it depends. It can take a minute or two. So it's quite friendly too. And then, anytime I want to use my endpoints now, I have to actually create a path parameter here and pass the API key. Otherwise, you get an unauthorized response. So that's one thing that's recommended is to secure your API. And then, what we would like to develop mobile application. It will be really nice to get some kind of SDK directly from my API gateway, so I can plug it into my iOS application and don't worry about accessing the API. So it's available. There is a few things we need to do to start developing this app. Essentially, right now I was able to define the API in my serverless file, all the operations. What I need to do, I need to actually tell the API gateway what kind of data I'm passing, because until now there was no information about the JSON that's coming across. So I actually have to define a model of my request and response in terms of JSON schema, JSON schema for what's coming in the body, and JSON schema for what's coming out as a response. Let's say if I get the list, I need to define a schema for listing of all the elements. So that's additional task, and then I will be able to use API gateway and tell, create SDK for me in whatever language I decide to. In this case, I like to use Swift for iOS, for example. So again, I need to add a few more things in my project. One of them would be the schema for the request. So essentially, I describe here's what's coming in terms of JSON schema. And as a response, some of the methods, let's say the list returns the list of items. So I need to describe also JSON schema for list. Again, in this case, this particular functionality is very Amazon specific. So Amazon API Gateway has this feature. So I actually have to download the AWS specific plugin. So it's not generic plugin. This only works with AWS, right? So now you start seeing it's not perfect for everything. So I need to actually deploy the serverless AWS model plugin that lets me define my models and tie them to my function definitions. So again, I need to install the plugin. It was installed successfully. And then I need to declare one more plugin in my serverless YAML file. And I need to define the model. So essentially, new section called models. And I had two models. One is the PyDia model, which is the model of the request, so the body of the request that's coming in, and the list model, so the response, right? And I need to assign this model to all the functions. So let's say function create actually request and response. So when I send it to my endpoint, I send the JSON, but it's also responding to it. It says 200 or something. Yeah, it says 200 response. Also responds with this, the JSON. So I need to do it for all of them. For list, I'm actually sending no model on the request, but the response give me the list of items. So I need to just describe this for each of them. For the get, I'm getting, I'm sending the. I'm just receiving the one instance, not the list, but just one. I'm not sending anything. For update, actually, I'm doing both. I'm sending one, and I'm receiving one. And for delete, again, I'm not using anything. So again, I remove the stack and redeploy. And then nothing changed. I still have 5 endpoints. And the how it looks in the API gateway, there is you see all my operations here now. The API gateway has a models section. So in this case, my 2 models were created, and you can do this by hand again, but we want to avoid that. So you tell API gateway, I'm going to use iOS Swift, and actually this can be also automated from command line, so you can actually get your SDK to your client automatically. And then for iOS, for example, you have to do the prefix, the typical, and then create the SDK library. And the way it looks is really, it's kind of model-driven library. So SDK, what you get is mimicking your API operations. So you have a post, you have a delete, you have get, you have put, and really the same thing. You get a class with your data structure, you populate, and you use the SDK from your mobile application. So it kind of simplifies your life as a developer. You don't have to worry about it. So I think that's everything I had today. Any questions?
Actually, we have a couple questions up on the screen, so if you want to repeat them, and then you can.
How do we get the slides? I can share it if you'd like to. So
we'll send out a recap and make sure they get put into the digital booklet.
Okay. What mechanism do you use to distribute the API key to authorized clients? It's a very good question. So a lot of things I was talking about. Let me see. Go back here. There's a few things that are not part of the talk, like authorization. Definitely you don't want to open up your API to just anybody, right? You need to know who performed the operation. So there's a lot more into the infrastructure than just what I demonstrated. But typically, in our systems, there is a business level agreement because our APIs are usually issued just for the client that we have some business agreement with. Then we would actually generate a unique API key for every request like that. And then there's things about refreshing and so on. So there is a lot more into this to build infrastructure to share your API key. It's not part of the, serverless can only do so much for you. This is more for development, but if you want to create your API key management infrastructure, there will be another level to it. Business agreement, make sure the URL that request is coming from is the right one. A lot of these things need to happen. So we would actually have a portal for the business people to, enter all the information, enter the URL that requests are expected from. So we have several levels of protection. So there'll be, to make this business ready, there is another new project just to manage the API keys, right? So I hope that answered the question. And then, so using SLS, can you retain some of the assets between deployments, such as database? Actually, that was one of my experiences. The DynamoDB won't let you delete your table if there is a data in there. So yes, you can, absolutely you can. I think, and you want to, right? Database, for example. But I believe beyond database, there should not be need. As Calvin was saying, the good practice is I shouldn't be attached to my infrastructure. I want to be able to take it down, and maybe even your load balancer will want to spin up new instances of it. So I think, again, this is more about designing the solution properly. But yes, you don't want command line to delete your database that has valuable data, right? So again, I believe by default your database is not deleted if you have something in it. So you actually have to go and get rid of it. it will always create a new table with different name for you. So if you want to keep just adding tables and use different ones, you can do that. I don't think you can change the name of the table in DynamoDB, so there's a lot of things you're not allowed to. But yes, that will be my answer to it.